Hi Chem 20s, Mr. Riley here. Just doing another video here. Topic we're looking at is limiting and excess stoichiometry. This is the third or fourth video in this series of limiting and excess reagents. What we are going to be doing here today is we are looking at, from a word problem, can we determine what is the limiting reagent in a chemical reaction? So for these problems, we're always going to be given the amounts of both reactants, and we're going to have to figure out which one's going to get used up, which one's going to be the limiting reagent, because that is the chemical that we would use to figure out the amounts of everything else in the chemical reaction. Okay, so here's the problem. I have calcium fluoride reacting with a concentrated sulfuric acid to produce calcium sulfate and the highly toxic gas hydrogen fluoride. So I've already written the balanced chemical equation below here, and I'm being asked to determine the limiting reactant when I have 10 grams of calcium fluoride. Okay, so let's add that in there. 10 grams of calcium fluoride reacts with 15.5 grams of sulfuric acid. So I'm going to show you a little bit of a different method than the one I did in the previous video. In this method, we are going to be comparing the two reactants to each other and saying, okay, well, if I'm going to completely react my 10 grams of calcium fluoride, how much sulfuric acid would that take? And do I have enough? If I don't have enough, well, then the sulfuric acid is the limiting reagent. If I have more than enough, then the sulfuric acid would be the excess reagent. Okay, so let's work this out here. So I'm going to start with my CaF2. So I have 10.0 grams of CaF2. And whenever I'm comparing two things in stoichiometry, I always need to get 2 moles. And so I can do that using a conversion factor of a molar mass. So my molar mass of CaF2, I've calculated it before, just got to turn on my calculator here, 78.08 grams per mole. Okay, and that's going to give me the number of moles of CaF2 that I have available in this reaction. Okay, now what I'm going to do here is I'm going to see how many moles of, actually what I'm going to do here is I'm going to calculate that value. And so I'm going to have 10 divided by 78.08, and so I get 0.128, let's say, of CaF2. Okay, and now what I'm going to do is I'm going to try to figure out, okay, how many moles of H2SO4 am I going to need to completely react that? And so what I can do with that is I'm just going to use my molar ratio, which is, I mean, in this case, it's a 1-to-1 ratio, right? So I get 1 mole of H2SO4 for every 1 mole of CaF2. So in order to completely react all my 10 grams of CaF2, I'm going to need 0.128 moles of H2SO4. Okay, now let's look at the other substance, the H2SO4. So 15.5 grams of H2SO4. I'm going to convert that into moles. So for every mole of H2SO4, there is a mass of, this is my molar mass, 98.009 grams. Okay, and so I'm going to do that calculation. I'm going to say, okay, 15.5 grams divided by 98.09. And that gives me 0.158 moles of H2SO4. And so in order to completely react my moles of H2SO4, Some of you maybe figured this out already. Okay, how many? We have 0.158 moles of CaF2. So looking at my numbers here, okay, from this, what is the limiting reagent? Okay, so if I want to completely react my 0.158 moles of H2SO4, I need 0.158 moles of CaF2. But I only have this much. 10 grams is equivalent to 0.128 moles. So I don't have enough calcium fluoride to completely react my sulfuric acid. Okay, so that makes CaF2 my limiting reagent. And you know, I can look at it the other way the same, right? So to completely react my 10 grams of CaF2, which is equivalent to 0.128 moles, I only need 0.128 moles of H2SO4. And I have 0.158 moles of H2SO4. So I have more than what I need. Now, the advantage of doing it this way is I could ask you a question like, okay, how much of your excess reagent is left over? And in that case, I could just look at the difference between 0.158, how much I have of my sulfuric acid, and 0.128, how much I need. So 0.128 is going to react, and the 0.158 is the total that I have. So I could just find the difference between those, which would be 0.03 moles. Okay, so that's another way. That's another way of looking at that. So this is going to be my limiting reagent. All right, so I hope that helps, and I'll see you guys next time.